In this lesson, we will go over the metal tubing used in aircraft fluid lines. Additional information on this topic can be found in Chapter 7 of the General Aviation Maintenance Technician's Handbook and in Advisory Circular 4313, Acceptable Methods, Techniques, and Practices of Aircraft Inspection and Repair, pages 819 and 820 and 919 through 926. Students often get impatient while cutting tubing, and having turned the tubing cutter a dozen times and still not having cut through, they over-tighten the tubing cutting tool to speed up the process. The problem is by the time they crank down on the tubing cutter, they are most of the way through the material. This often results in the flattening of the thinned tubing, causing them to have to make another cut. Wrinkled and kinked bends must be discarded and not used in the aircraft. Slightly flattened bends may be used if the most narrow point in the bend is not less than 75% of the outside diameter of the straight portion of the tube. A double flare is used to strengthen the material in the flare. This series of diagrams is here to illustrate the major steps in the flaring process. The difference between the instructions for forming a flare with an impact flaring tool as opposed to one with a threaded flaring plunger is that the threaded flaring plunger is screwed into the grip die rather than being tapped into with a hammer. The ferrule cutting into the tubing as the nut is being tightened secures the tubing in place and helps to seal it. All fuel lines must be supported and bonded to the structure with a maximum distance between supports as given in this chart.